How can I lower my environmental footprint? The aim of the investigation is to use mathematical strategies to find out if taking public transport has less environmental impact than driving a car to work every day. I will examine the consumption of petrol used to drive 60 kilometres every day to and from work, 5 days a week. Through mathematical problem solving, I will measure the cost and consumption of fuel used in private transportation and in taking the bus to and from work. I will examine how much CO2 emissions the bus and car use on my 5-day work trip. Findings will either support the bus or private transport using less fuel. Therefore, my actions will impact less on the environment. Brainstorming gives me a basis to begin my problem, so I have outlined the information that I think I will need to solve the following equations. Facts pertaining to the equations such as CO2 emissions, how much fuel costs are outlined here. More information such as the distance between Mackay and Sarina and the bus fare, schedule and pricing have been found which are pertinent to solving the mathematical problem. All the information I need for my equations to solve my problem are found in boxes. I've arranged them so they are easy for me to find and use. I've rounded the petrol consumption and the distance to Mackay and Sarina to whole numbers to make this easier in my equations. These are the steps in how to begin solving my problem. I'm starting with distance travelled as I need to use distance in other equations further along in the problem. The first part of the problem is to find out how far I travel on a return trip each day, week and year. One way to town is 30 kilometres. Therefore, I multiply it by 2 to find out the total distance per day, as there is a trip to town and a trip home. To work out how far I travel each week, I multiplied my daily distance by 5, as there are 5 working days per week. I took the weekly travel distance, multiplied it by 52 weeks to find out how far I travelled per year. As a car uses 14 litres of fuel per 100 kilometre, I want to know how much fuel is used per 1 kilometre. Therefore, I divide the 14 litres by 100 kilometres to find out how much fuel is used per kilometre. 0.14 litres per kilometre is the answer. I then multiply this by the distance I travel each day, week, in year to find out how much petrol I use on those trips. To work out how much the cost of my trip to and from town is in terms of the fuel I use, I have multiplied the cost of the fuel per litre by how much fuel I've used per day, week and year. The working out I showed is exactly what would be going through my head when I was writing it down in a book. Now, these equations can be solved very easily with a calculator, but as we know, calculators are only good as the operators. Therefore, I actually did use this written down equation to check my answers, because this was one of the answers that I was concerned about or I had mucked up the first time round. So the working out, like put down the 6 and carry the 3, that's exactly what would be going through my head as I was solving this problem, writing it down on paper. The bus costs per day and per week were found on the bus website, and I've used how much it costs to travel per week on the bus, times that by 52 weeks in a year to find out how much it will cost me to travel on the bus per year. The car and bus emissions are simply using how many grams of CO2 and timesing it by the travelling I'm doing each day. So, for example, the car is 133 grams of emissions. I times that by the 60 kilometres I use in a daily trip, and that will give me my answer. I follow this pattern through for both car and bus over the day, the week and the year. I've gathered all the information that I've found through problem solving in the previous equations and placed them here in this table for easy to read. This allows me to compare costs per day, per week and per year quite easily. This is the outcome of the cost of travelling in my car to and from work and travelling by bus. The bus is cheaper to use as transport to and from work. Throughout the year I actually saved $593. I think the cost is important to the problem of lowering my footprint, because if the bus cost was more than the car, I would have to choose another way to lower my footprint. The outcome for the CO2 emissions versus the car and the bus work out in favour of the bus. There's a clear decrease in the amount of CO2 emissions used. So the total savings of travelling to and from town were 800,800 grams by bus. So this would lower my footprint. However, I have found a discrepancy when I've been typing up my findings. The number in red is actually incorrect. So it does pay to actually check your work for mistakes. So the overall outcome. The question was, how can I lower my environmental footprint? So through the findings of the equations, the mathematical working out, I'm able to lower my environmental footprint by taking the bus to and from work every day as opposed to driving my own car. So taking the bus over driving my own car lowers the CO2 emissions I'm producing by 800,800 grams. Less CO2 emissions means clearer air, less smog and a better environment. As a bonus, I'm also saving $593.32 a year by catching the bus. The mathematical problem, public transport versus private, aligns with the Australian Mathematics Scope and Sequence from grades 4 to 7. The problem correlates with outcomes in money and financial mathematics, patterns in algebra, real numbers, fractions, decimals and number, place and value. Outcomes include investigate and calculate best buys, use all 4 operations to solve problems with whole numbers and add and subtract decimals. Under data representation and interpretation of the Australian curriculum, children need to be able to create displays of data using lists and tables and interpret them. This is evident in the mathematical problem public transport versus private. I completed each mathematical step individually. I used tables to keep each part of the problem clear and easy to interpret the facts. I feel that if I didn't separate all the facts, I would have made a mistake. Although I used a calculator to work out the problems, I have showed my working for written equations also, as I use them to double check my working out. I believe this problem would be best suited for groups where discussions can take place. I found I kept second guessing myself and wanted to talk about the problem to see if I was on the right track.